So hopefully this will help you study for your test on Thursday. We're serious. No moms. Okay, so we have ABC with the right triangle with the angle at B. So we draw this. Draw your right triangle with your angle at B. And A and C don't really matter. But I'll put it here and here just for fun. AB is 10, and this is 10 units here. Angle A is 48 degrees. And we're looking for AC. So there's your X, your hypotenuse. So we know an angle, we know a side length. We're going to use trigonometry. For angle 48, this is the adjacent side. This is the hypotenuse. So we're going to use the cosine function. So cosine of 48 equals adjacent over hypotenuse. And as we've learned, when x is in your denominator, we end up dividing. So 10 divided by the cosine of 48 turns out to be approximately 14.95 units if you want to round to 2 decimal places, or 15 if you don't. Okay? So because we have the adjacent and the hypotenuse, we use the cosine. The adjacent goes on top, the hypotenuse goes on bottom. Okay, number 2 is similar. We have the same type of triangle with angle B as your right angle. So we'll put A and C wherever you want to put A and C. We have AB is 10 units long once again, and BC is 15 units. What is the measure of angle C? So angle C is your variable, theta, alpha, beta, whatever you want to put in there. So for angle theta, this is the opposite side and this is the adjacent side. So we're going to use the tangent function. So the tangent of C, so we're looking for angle C. So tan of C is the opposite side divided by the adjacent side. And we always solve angles by taking the inverse. So some of your calculators have this as a button. Sometimes you have to press it after you do the fraction. Just be sure you can use the calculator that you are assigned. The inverse tan of 10/15 turns out to be about 33.7 degrees as your answer for that one. Okay, so sometimes you find sides using the trig functions. Sometimes you find angles using trig functions. Okay, on 3.1, we're looking for the length of AB. Okay, we know this much is 12, we know that much is 20. So because we have right triangles with right triangles, we're going to set up and solve a proportion. In fact, this is going to be a non-altitude proportion. For those that have watched the video about special right triangle similarity, this is a non-altitude proportion, which says you take the hypotenuse and you divide it by the leg. That will be in proportion to dividing that same leg by the segment that is closest to it. So here your hypotenuse is 32 units long. The leg is x, AB, what we're trying to find, equals x over the leg closest to that, which is 12. So cross multiplying, we have x squared equals the, whoa, not square root yet. Hang on, that's huge. X squared equals 32 times 12. Let's see what that is real quick. 32 times 12 is 384. So finally, square rooting both sides, x is approximately 19.6 units long. Okay? So you should remember, whenever we have a right triangle with a right triangle, you're going to use some type of a proportion, either an altitude proportion or a non-altitude proportion. Okay, like we're going to do on number 4.1. So our final goal is to find the length of BC, which is way down here. Okay, far, far away from our two sides that we know. But because this is a right triangle and we know two sides, we can apply our Pythagorean theorem. 24 squared equals 12 squared plus, in this case, BD squared. Because we're going to find BD, and then we can find DC, and then finally we'll find BC. So there's lots of work to be done in order to get our answer. So we start with Pythagoras. We find out that BD is about, well, it's exactly 12 roots of 3. So let's see what that is approximately. 12 times 3 square root. No. We'll do 3 square root times 12. 20.78. We'll go 20.78. So now that we know this, this is our altitude, we can use our altitude proportion to figure out what DC is. So our altitude proportion goes, the segment over the altitude is in proportion to the altitude over the rest of that hypotenuse, in this case DC. So we use Pythagoras to find the altitude here. We use the altitude proportion to find this leg, which it turns out is 36 units long when you cross multiply and divide by 12. And now we can solve for x a number of ways. Let's go ahead and use Pythagoras. 24 squared plus x squared will equal 36 plus 12 squared, which is 48. Okay, you could have also used this little triangle down here, but here we have a decimal. I would rather much use whole numbers. They're easier to calculate with, and they give you nice rounder numbers anyway. So it turns out when we solve for x, we get 41.6 units is the length of BC. Okay, so we use Pythagoras to find the altitude proportion to find the segments here, and then I use Pythagoras with the entire large triangle to figure out what this side is, BC. We could have also used Pythagoras with our smaller triangle. We could have also used a non-altitude proportion with the hypotenuse and the leg and 36. Okay, lots of ways to do that. So let's go back up to the top. Question number 5. Here we have similar triangles, so we have proportional sides. AB over XY is in proportion to BC over YZ is in proportion to AC over XZ. Okay, it all comes by the letters and their ordering. So AB is 4, AC is 9, AC is 9, XY is 6, so 4 over 6 is in proportion to, we're looking for XZ. So we solve proportions by cross multiplying. 4xz's, which is your variable, is equal to 54. Dividing both sides by 4, xz turns out to be 13.5. So anytime you have similar triangles, your sides are in proportion. So you set up a proportion, you cross multiply, and you get your answer. Okay, from the top of a 210-foot lighthouse, the angle of depression to a boat is 27. So we are here. Here is your water down there. If this is your horizontal from where you are, your angle of depression down here to the boat is always floating in the sky. 27 degrees, this is your angle of depression. Okay, this is your boat down here. Because it's 210 feet tall, okay, we're going to transpose the lighthouse, which is really here, 210 feet. is also 210 feet there. So we want to know D, the distance from the boat to the foot of the lighthouse, okay, which would be this distance along the water, but because your triangle's in the air, we're going to find the distance in the air. Okay, so the key is putting this angle up here floating in the sky, not here with the lighthouse. It's always made with the horizontal. So tan of 27 equals 210 over D, opposite over adjacent. We're going to end up dividing 210 divided by the tan of 27. And it turns out that distance is 412.2 feet that the boat would have to go to get to the foot of the lighthouse. All angles of depression are drawn in the sky. Okay, the triangle is made in the sky. Yeesh.
Hi, Mom.
No moms. So whenever you're finding the angle of depression, make sure you're drawing the triangle in the sky, and your angle goes up here in the sky. Okay, everything is floating in the sky. Okay, good old Susan. I don't know who Susan is, but here she is. She stands 10 feet from a building.
Susan's my aunt.
Susan's your aunt. Okay, so here is the building. Here is Susan. She's 10 feet from the building. Her eyes are 5 feet above the ground. So here is her horizontal. She is not laying on the ground. She is standing, so 5 feet. And here is her 70-degree angle of elevation. So when we set up and solve our trig problem, we're only going to find this much of the building's height. Okay, we find to here because that's where our triangle is formed, with her head, with her eyeballs, her angle of elevation, and her horizontal. So when we set up our tangent, tan 70 equals h over 10, okay, she's 10 feet away from the building, we get a height of 27.5 feet. Okay, not a tall building, but a building nonetheless. So if this much is 27.5, we need to add in the additional 5-foot height of her eyeballs in order to get a total building height of 32.5 feet. Okay, so when you set up your trig, you're not finding the entire height of the building, you're just finding the height of that triangle edge. You have to continue to add until you get to the ground. Okay, sometimes they're tricky. And let's see, John is fencing a rectangular pen. So we have two sides we need to find, the vertical side and the horizontal side. We both use tangents. Tan of 32 equals opposite. Nope, tangent is a lie. How come you didn't catch me? This is the sine. If y is the opposite, we're going to use the sine is y over 15, the hypotenuse. And then we're going to use the cosine to figure out x, because x is the adjacent side. Okay, y is the opposite side to 32, x is the adjacent side to 32. Turns out that y is 7.95, x is 12.72. Okay, when you solve this, make sure you're cross multiplying. So adding them together, the total fence that we need to purchase will be 41.34 feet, or about 42 feet, because you have this 7.95 and this 7.95, and both of these 12.72, so it's a perimeter problem. Okay, and our last fabulous one, you're watching a helicopter fly straight up. So if this is your helicopter, it's going straight up. Here's your helicopter. Here are you. You are 100 feet from the helicopter. And you are on the ground, by the way. So if this is your ground, there's a bump. You are 100 feet from directly below the helicopter. So neglecting your little eye heights, this is going to be the initial height of your helicopter. when your angle is 32 degrees. Okay, so we're able to find the initial height. The tan of 32 equals h1 over 100. And it turns out that the original height was 62.5 feet. So when you first saw this helicopter, it was 62.5 feet off the ground. Okay, now 20 seconds later, the helicopter's way up there because now you have a 75-degree angle. So here's a helicopter now way up here. It's smaller because it's higher. We can't see it as well. And we can figure out what the second height is. So you're still 100 feet away, so we're still using the tangent. But tan of 75 equals h2 over 100. So now the helicopter is 373 feet off the ground. Okay? Which means, of course, that the distance that it traveled was 373 minus 62, which is about 310.7 feet. So in that 20 seconds, it traveled 310 feet. So for our final question, what is the rate? The rate is the distance divided by the time. 310.7 divided by 20 seconds. Looks like it's 15.5 feet per second, which, if you recalculate, is 930 feet per minute. Okay, so remember when it asks you where it gives you a time and it wants a rate, you need to use the rate is distance divided by the time, 15.5 seconds. Okay, go be smart. Goodbye.